Alright, in this video we're going to be looking at soil properties, going through texture, structure, composition, and optimal pH. So let's go ahead and get started here. We know that if you look at the different layers of the earth, the lithosphere, asthenosphere, all those different layers, outer, inner core, we know that our soil is that very top layer. It's very thin compared to the rest of the layers of the earth. That's where all these nutrients are going to be found for life, for plant life to grow. What we're going to be looking at is what a soil profile is, how we can look at a soil profile to identify these different horizons or layers, and then the types of materials that are going to be found in each horizon or layer. There are 6 major types of horizons. We're going to be focusing on just 2 or 3 of them, especially for in this area. But we're going to look at all 6 just for identification purposes and the material that make up each layer. The 3 main types, A, B, and C horizons or layers, these are the 3 that we're probably going to find in this area. But as far as the 6, you've got O, B, C, and R as well. Alright, let's start looking at these a little bit more closely. The O horizon is where most of the decayed plant and animal material is going to be found. It's going to be this very thin layer, just a few millimeters thick of organic material. We're going to call this humus. And this is nature's natural fertilizer. Most of the ecosystems might have small traces of this, but you're going to find that the forest ecosystems is where most of your humus is going to be found. Grasslands, very small amounts. Deserts, none at all. Tundra, hardly any at all. And it has to do with the lack of plant diversity and plant recycling that occurs in those different ecosystems. Whereas the forest ecosystem, you have a lot of leaf fall, you have a lot of leaf litter, debris, brush, those types of things that get recycled in large amounts. This picture that you see, we're going to be looking at a few different pictures as we go through. This is a picture of a particular type of soil profile. This one's actually a forest soil profile, and if you notice about these different profiles, you can see the different horizons or layers, mainly due to the different colorings and the thicknesses, and that goes into the materials that make them up. For our organic layer or our O horizon, it's going to be this very tip-top, very small, thin of humus that's located at the top of the profile. Alright, the A horizon. Most all soils are going to contain at least some of this A horizon. This is going to be our topsoil. It's where most of the nutrients are going to be located. Most of the nutrients for plant growth are going to be found. If you look at this soil profile and notice that darker layer at the top, most of the A horizon examples will have this particular characteristic. That dark layer is going to be provided, or it's going to be dark because of the nutrients and the microbes and the recycling that's occurring for nutrients in that particular layer. Alright, there is an E horizon, and most times you can find an E horizon in each profile, not always. For example, here in this area, we don't have the E horizon, and it has to do with the fact that this E horizon shows up when you get a lot of irrigation occurring. This leaching process occurs where the chemicals and organic matter are being leached out of the soil, and is forming this thin little layer where leaching occurs. Our process has occurred so quickly and so long ago that this E horizon isn't viewable within the profiles within our area. We do have the B horizon. And the B horizon is mainly going to be subsoil, and this subsoil is going to be mainly made of clay. If you remember from our soil profile lab, the soil profile that we did have a very thin piece of the A horizon, or the topsoil, but most of our soil sample was made up of that subsoil that was mainly clay. Clay is very good, and you want to have a large amount of clay within your subsoil because it's good at holding water. Plant roots are able to grow down into the clay and access that water, and so it usually gives them an abundant supply the further down they can go. Alright, let's get the rest of these characteristics for these horizons. Our C horizon is going to be our parent material. If you remember from last semester, our parent material is going to be the rocks. Rocks get weathered and eroded, broken down into sediments, and they get moved around to different places, and that sediment is what is going to go into forming our soil. And so our parent material is going to be the rock, that foundation for soil building. And then the last horizon is our horizon. There has to be a foundation for this to stabilize the soil, this top layer, and so the bedrock is going to be this our horizon, this foundation. You remember when we looked at types of rocks, we looked at metamorphic, igneous, sedimentary, and of those three categories, these are the most common types of rocks that you can find as bedrock, being limestone, sandstone, or granite. Granite being a very good one, just due to its durability. Sandstone, limestone, though, also depending on location, close to water, not, those types of things could be common types. Alright, here are two other pictures of soil horizons, and you can notice the different layers, how they form, where they're located. Notice the O is very, very thin layer at the top, that organic matter. Then you get your topsoil, your subsoil, then your parent material, and bedrock. Alright, let's get into soil texture. Soil texture and soil structure kind of go hand in hand when looking at the health of soil for plant growth. So let's focus on soil texture first. Soil texture does refer to the size of the particles, and that's important because depending on the size of the particles that are mixed together, that will help determine the amount of room for water and nutrients, microbes, worms, those types of things to keep the health of the soil intact. There are three types of particles that make up texture, and they go from largest to smallest, sand being the largest particle, silt, and then clay being the smallest. Now your sandy soils, these are the largest particles. Sandy soils are very good with space, but they are not very good with holding water. So think of beaches, deserts, not very good at holding water. So you don't want too much, for example, of one type of particle making up your soil texture. Too much sand, too much clay, too much silt will offset the others, and it'd be actually a poor mixture. So having a nice, even mixture of these three particles could give you the best type of soil texture for plant growth. And this nice, even, equal mixture of sand, silt, and clay, we're going to call it loamy soil. This loam soil is ideal texture for plant growth because it provides the right amount of space, the right amount of water holding capacity, the right amount of nutrient holding capacity for plant growth. And then once again, if you have too much of one texture, for example, clay, very, very good at holding water. However, it doesn't have as much room for air capacity, doesn't have as much room for nutrient capacity, and so once again, you run into too much of one particle for texture can be a negative. So having that loamy soil, those equal amounts, is what is strived for. Most of the places in the U.S. are going to lack a good loamy soil. The Midwest regions are very good, or at least they used to be, for our plant growth because of the amount of loamy soil that they had naturally occurring. There are 12 different textural classes. We're not going to get into all of them, but there is a triangle on the next slide that's going to represent or give you a representation of these. So you have this at your disposal to look at these different classes. Alright, let's go ahead and jump into soil structure. Soil structure closely related to soil texture as far as being beneficial to plant growth. Soil texture, remember, was about those three particles that make up the texture. Soil structure is going to talk about how your soil actually forms together and sticks together to form these units or aggregates. It's going to get into the amount of space, the space to store air, space to store water, nutrients, and allow for root growth. So let's look at these different structures. There are 5 major types: grainy, granular, single grain granular, platy, blocky, and prismatic. Your single grain is like sandy soils, your beaches, your deserts. Your granular is going to be the best type of soil structure for plant growth. You're going to find this in certain grassland ecosystems, definitely forested ecosystems. Your A horizon is going to contain a lot of granular soils, and it's going to provide the right amount of space, once again, for water capacity, air capacity, and root growth. Platy is usually going to be found in your E horizons. Right, remember the E horizon where you have that leaching process occur between your topsoil and your subsoil. That's usually going to be the platy. It's going to have it's where clay is starting to form, and it makes these plate-like structures, but it's lacking in nutrients, maybe water, and so it's going to form these plate-like structures. You get your blocky type structures in your subsoil, right, or your B horizon, where you have a large amount of clay. It's going to hold a large amount of water, and it's going to form your blocky structures. So your A horizon is going to be granular for the most part. Your E is going to hold your platy. Then your blocky can be found in the B horizon. Now prismatic is usually going to be found in areas where you have a lot of mineral deposits, say close to caves and those types of places. You're not going to see prismatic a lot around here. You can find these massive structures or clod structures, especially when tilling for plant or crop fields and those types of things can occur. Alright, soil composition. A nice balance of soil composition is going to lead once again to overall plant health and plant growth, increased plant growth. You want about 50% of your soil composition to be made of solid material, about 40-45 of it going to be your minerals, and then the last little 5-10% being your humus or your organic matter. The other 50%, you want about half of that being water for water space, and you want half of that being airspace to get a nice composition where you get enough water, you get enough air, but most of it, half of it's going to be given over to minerals and nutrients and your humus. Alright, and lastly, let's look at pH. Soil pH, we've talked about pH, especially when we got into acid rain a few units ago, how pH is very important to soil because plants need a particular type of pH for optimal growth. A quick little review on the pH scale. We know it goes from 0 to 14, 0 to 6.5 being your acids, and above 7 to 14 being your bases. As far as plants go, as far as the growth of the plant life, grasses, shrubs, trees, optimal pH range is roughly around 5.5 to 6 up to 7, 7.5. So you're looking at more just barely, like slightly acidic up to neutral as an optimal pH range. So to take away from this, soil structure, soil texture, soil composition, and its benefits to plant growth.